Hello everyone, welcome back to the Swift Academy. Today we are trying to solve another LeetCode problem, number 704, as it says that it is binary search and it categorized as easy problem. But so many issues and questions during your interviews related to the binary search. So by implementing the binary search, you are going to learn a lot and solve many issues related to the problem that your interviewer tell you to solve by using this methodology. So bear with me, we are going to learn the binary search section by section and trying to solve this problem. This problem asking us to go through one array, as you can see here, and find one object inside it. So one simple approach is that to going through the whole elements. For example, if we have all the elements here, we start from the beginning in a for loop approach and testing all the objects there. If it is the target, then go on to the next or to the next and then to the last one. If the target exists, then we are going to returning true. If not, then we are not going to return anything. And also this question is going to ask us to return the index of the target. For example, now we are looking for the 9 here as a target, but the question asks us to just retain the index number of the target. For example, now the target is 9 here and the index of the 9 is 4. So we are going to return 4 as the answer of this object. But how we are going to get to that point, to getting the index of the target in the log n complexity? You know that if we go into that the all objects, it means that we have the on. On is not so bad, but we want it faster and better. So the better approach will be O log n, and we don't need to do the on approach through the one for loop. So let me explain more about how we are going to achieve the binary search in a sorted array. The array that we are working on that consists of these numbers: -1, 0, 3, 5, 9, and 12, and the target is gonna be 9. So we have to go through this array by using the binary search to find the 9. But how it is really working? We are using the two pointers method, one at the beginning and one at the end, and then trying to solve this problem. So we have one pointer as the beginning and the other one as the end, and then we are going to find the middle. For example, the index of the first pointer is 0 and the index of the last pointer is 0, 1, 2, 3, 4, 5, and the midpoint is gonna be 2. So the midpoint is now 3. So definitely from here we are going to check that if our object inside the index m is greater than the 9, our target, or not. So if it is greater than the 9, it means that we have to look through this portion of the array. But if it is not greater than 9, it is smaller, it means that we have to go forward and look inside this portion. So by simply cutting half of the array at each iteration, we are going to achieving to finding our target very faster and sooner. So as I said, we are on a sorted array. So because already this array is sorted, we don't need to worry about the sorting thing here. Okay, now let's continue. We find out our object is not equal to the middle index, and also our target is bigger than our middle index. So the first pointer is gonna be changed now, and the first pointer we are going to move it here. So now our first pointer will be now at the 3. So the middle one between the first pointer, that 0, 1, 2, and the 5 is gonna be 9, and this is our middle one. Now we are checking that if our middle index is equal to the 9 or not, that our target. Yes, it is. So we're just returning the M index. And with that approach, we are going to always cutting the array, already sorted array, and moving forward and changing the pointer always. If, for example, we are looking for the 0, it means that we have to again going to remove all the objects here. Let me change the color. All the objects here again by having the pointers. So starting from the first pointer here, the first index is 0, the last index is again 5 here, and now the middle one is 3. Okay, we are looking for 0. This is our target. When we reach to the middle index, we check the middle object by the index of the M. It is 3. Because we are in the sorted array, we are asking that, okay, 3 is greater or 3 is smaller than the 0. So we only going to remove this portion of the array and checking to remove the objects here. So then we between the 3 and the -1, we can just simply find the middle point and then check the middle point if it is equal to our target or not. We can find it, yes, it is equal, then it will be our answer. The index will be our middle index then. The reason for the best efficiency for this approach is that we are cutting the array objects, the total objects inside our half and half and half. For example, if we have 16 objects there, we cut it to the 8, then we again half it to the 4, then we again half it to the 2, then we again half it to the 1. And if the one object inside our array is not our target, then it means that it doesn't exist. You remember during your schools, maybe we have the log to end there. So when you are always cutting your objects or total number of the arrays, you are going actually the approach of the log n. Inside the time complexity table, the on will be here, but the O log n, it's much better approach for solving such these issues when you are dealing with the sorted array. So always during your interview, tell the interviewer that you can solve it during the on, but the better approach for the sorted array gonna be a binary search that you are going to call the O log n and solve this issue. Okay, now we are going to code this approach in Swift language. As you remember, we are talking about the 2 pointers. So we need one pointer at the beginning and one other pointer at the end. For example, for this array, -1 and 12. So we are going to have one variable here called left index, and it should be an integer, and I will call it 0 and assign it to the 0 because the first index will be 0 always. For the right index, I'm going to just call it as the total objects inside our array here, that our array name here is the nums, and it should be the count, and it will be returning back to us just the total numbers of the object. But you remember, it isn't returning back the exact number. We have to do it -1 in Swift. So now we need just a loop. That loop will be available, will be going through until the left index is greater or equal than the right index. It means that when we reach to the end, just one object remain inside that, the left index and the right index is going to be equal to the same pointer. So until that moment, we are still inside the while loop. Either we find the target, or either we didn't find anything and we just returning the false or returning the the index that is not available inside our object. So now we are going to creating our middle index. Let middle index is gonna be our left index plus right index, and we have to divide it by the 2. Then let me check the middle value. Let middle value is gonna be our array. Here is the nums and our middle index. So the only things that remain here is to check if the middle value is equal to our target or not. If middle value is equal to our target, if it is equal to our target value, it means that we can simply return the mid index here, middle index, because it is asking us to returning back the middle index, the index of the target number. So if it is not, we are going to returning -1. But wait a minute, we are in a while loop and we are doing the binary search. So the else will be checking if the middle value is greater than our target or not. If middle value is going to be greater than our target, then it means that we have to move our right index. So right index is gonna be our middle index -1, and the other side, if the middle value is gonna be smaller than our target, because we are on a sorted array, we have to move the left index, the left pointer. So left index equal to the middle index +1. If we found something, at this point we are going to returning the index, but if we didn't find anything, the question is going to ask us to just return the -0. So at the end, if we exit the while loop and we didn't find anything, we just simply returning the -1. Oh, we forgot to put if here, so else if middle value. And now let me submit code. This is the result of the submit, and I believe that if we submit it again based on the performance of the CPUs and what else behind the LeetCode, it will be better and better. So this is how we are going to solve a binary search algorithm inside the Swift language. Hope you like it. Please subscribe and like this video to see more content like that and tips for your interviews. Be successful.